Good morning, students. Today we'll be doing the numerical problems on Newton's second law of motion. The first question is, what is the change in momentum of a car weighing 1500 kg when its speed increases from 36 km per hour to 72 km per hour? Now first, as I taught you earlier also, you have to write down the given data along with symbol and SI unit. If it is not given in SI unit, you have to convert to SI unit. So mass M is equal to 1500 kg. Kg is SI unit, no need to convert. Initial velocity U is equal to 36 km per hour. So this is not SI unit, we have to convert it into meter per second. SI unit of velocity is meter per second. So we are converting kilometer per hour to meter per second by multiplying it with 5 by 18. So we are getting initial velocity as 10 meter per second. Similarly, final velocity V is equal to 72 km per hour. Multiplying with 5 by 18, we are getting 20 meter per second. Initial momentum, as we know, momentum is equal to the product of mass and velocity. So initial momentum will be mass into initial velocity, that is mu. 1500 into 10, that is 15,000 kg meter per second. Note that the SI unit of momentum is kg meter per second. Similarly, final momentum mv is equal to 1500 into 20, that is 30,000 kg meter per second. The change in momentum is final momentum minus initial momentum, that is mv minus mu is equal to 30,000 minus 15,000 kg meter per second, that is 15,000 kg meter per second. Now we are moving to second sum. A man throws a ball weighing 500 grams vertically upwards with a speed of 10 meter per second. What will be its initial momentum and what would be its momentum at the highest point of its flight? This is actually a sum of free fall when the ball is moving upwards. For this sum, we need to have a proper concept that whenever anything is thrown in upward direction, it is working against gravitational force, and that is why it is decelerating or retarding. And finally, whenever it is reaching the final velocity 0, the body stops and it starts moving downwards. Look at the diagram given beside. So, till the point a body is reaching its 0 velocity, it is moving in upward direction. So at the highest point of its motion, the velocity becomes 0. That is the key point of this sum. Mass M is given 500 kg. Initial velocity 500 grams, so we need to convert it here. So a conversion is needed. We are dividing 500 by 1000 to convert it into kg. Initial velocity is 10 meter per second and final velocity v is equal to 0 at the highest point. So initial momentum is 500 by 1000 into 10 and final momentum is 0. Now question number 3. What force would be needed to produce an acceleration of 4 meter per second square in a ball of mass 6 kg? Here mass is given in SI unit. So m is equal to 6 kg. Acceleration is also given in SI unit. A is equal to 4 meter per second square. And we know the mathematical formulation of Newton's second law of motion. F is equal to ma. So F is equal to 6 into 4. We are putting the values there. So F is equal to 24 Newton. The fourth sum says that what is the acceleration produced by a force of 12 Newton exerted on an object of mass 3 kg. Here mass m is equal to 3 kg, force 12 Newton. F is equal to ma, so 12 is equal to 3 into a, that means acceleration. A is equal to 12 by 3, that is 4 meter per second square. The fifth sum is calculate the force required to impart to a car a velocity of 30 meter per second in 10 seconds starting from rest. Here the mass of the car is 1500 kg. The initial momentum is initial velocity is u. The final velocity is v, 30 meter per second. Time is 10 seconds. Acceleration a is equal to v minus u by t. So 30 minus 0 by 10, that is 3 meter per second square. Again we are using the same formula, F is equal to ma. So F is equal to 1500 into 3, that is 4500 Newton. Next question is, it is from graphical representation of motion. We have already done in the previous chapter. A speed time graph is given, and the car, it is a motion of a car, and the mass of car is given 1000 kg. You have to find out the distance traveled by the car in first 2 seconds. This we know, we have done it in previous chapter. And what is the braking force? The word braking is very important here. It's meaning a retarding force applied at the end of 5 seconds to bring the car to stop within 1 second. So distance traveled in the first 2 seconds is obtained by the area under the line AB and the time axis. So area of the triangle AB2, half base into height. So half into 2 into 15, that is 15 meter. Acceleration between 5th to 6th second is obtained by slope of the line CD, that is perpendicular by base. So 0 minus 15, why 0? Because 0 is the final value of speed and initial value of speed is 15. So when it is becoming 0, the corresponding time is 6, and when it is becoming 15, when it was 15 earlier, the corresponding time is 5 seconds. So 0 minus 15, 6 minus 5. So minus 15 by 1, that is minus 15 meter per second square. As because acceleration is coming in negative, so it is actually telling that it is a deceleration, and deceleration value is plus 15 meter per second square. Force is equal to m into a, so 1000 into minus 15. So force is coming as minus 1500 Newton, or braking force is 15,000 Newton.
Now we are moving to 7th question. A truck starts from rest and rolls down a hill with constant acceleration. It travels a distance of 400 meters in 20 seconds. Find its acceleration. Find the force acting on it if its mass is 7000 kg. Here the distance is provided and time is also given. Remember, we are depicting the distance with the letter S, not with D. S is equal to 400 meter, time t is equal to 20 second, mass m is equal to 7000 kg. All are given in SI unit, so there is no need to convert anything. Initial velocity u is 0 because it starts from rest. So here we have to use the concept of equations of motion, which is learned in last chapter. So S is equal to ut plus half at square. 400 is the distance. We are replacing the value of S with 400 is equal to 0 because u is equal to 0 plus half into a into 20 square. By calculating, we are getting the value a, that means acceleration is equal to 2 meter per second square. Now we'll be moving to the mathematical expression of Newton's second law, that is force is equal to mass into acceleration. Mass is 7000 and acceleration is 2. That is giving us that the force is equal to 14,000 Newton. Question number 8. Which would require a greater force? Accelerating a 10 gram mass at 5 meter per second square or a 20 gram mass at 2 meter per second square. Remember, both the masses are given in gram, which is not an SI unit, so we need some conversion. We know that from gram to kg, when we are converting, we are dividing by 1000. So 10 gram is equal to 10 by 1000 kg, and 20 gram is equal to 20 by 1000 kg. You can reduce that also. I did not reduce. If you want to reduce, you can reduce at this stage. Now in first case, F1 is equal to ma. So 10 by 1000 into 5, 5 is the acceleration. So the force is equal to 0.05 Newton. And in the second case, 20 by 1000 into 2, that is the force is 0.04 Newton. So comparing the two values of F1 and F2, 0.05 is greater than 0.04. So greater force is exerted by the body 10 gram having 10 gram mass, and which is accelerated with 5 meter per second square acceleration. Now let us do ninth sum. A force of 5 Newton gives a mass m1 and acceleration of 8 meter per second square, and a mass m2 and acceleration of 24 meter per second square. What acceleration would it give if both the masses are tied together? Here the masses are not given, so we have to find out the masses, then we will use the equation F is equal to ma. So in first case, the force is equal to 5 Newton, mass m is equal to m1, and acceleration is 8 meter per second square. So as force is equal to mass into acceleration, 5 is equal to m1 into 8, and m1 is equal to 5 by 8 kg. We are converting it into decimal. You may not convert also, you can work with fraction if you are comfortable with. 0.625 kg, and in the similar manner in the second case, mass is m2 and acceleration is 24. So we are getting 5 is equal to m2 into 24. So m2 is equal to 5 by 24 kg. When converted, 0.208 kg. In the third case, force is equal to 5 Newton, but the masses are tied up. So total mass will be m1 plus m2, that is 0.625 plus 0.208. So the total mass is coming 0.833 kg. As force is equal to m into a, so 5 Newton force is equal to 0.833 into a, final acceleration. So final acceleration is 5 by 0.833, that is 6 meter per second square. Question number 10. An unloaded truck weighing 2000 kg has a maximum acceleration of 0.5 meter per second square. What is the maximum acceleration when it is carrying a load of 2000 kg? So mass of unloaded truck m is equal to 2000 kg, acceleration is provided, a is equal to 0.5 meter per second square, as force is equal to ma, that is equal to 2000 into 0.5, that is 1000 Newton. Total mass of loaded truck is 2000 plus 2000, that is 4000 kg. So 1000 is equal to 4000 into a, so a is equal to 1000 by 4000, that is a is equal to 0.25 meter per second square. Moving to the last sum, that is 11th sum. How long does it take a force of 10 Newton to stop a mass of 2.5 kg which is moving at 20 meter per second? This particular sum has a twist. This sum is very important when you are doing it in your classwork notebook. Please put a star, because here you have to assume something. Let us start with the given data. Mass m is equal to 2.5 kg. Force F is equal to 10 Newton. So here we have to assume, as because the body is stopping, it is given in the question. So the force will be taken as retarding force, and if applied force is 10 Newton, the word retarding means the force is applied in opposite direction to stop the motion. So in that case, when you are expressing
it as returning force, it has to be minus 10 Newton. Force given is 10 Newton and returning force will be minus 10 Newton. If you don't convert these, your answer will be wrong. So beside this line, this conversion, put a star. Initial velocity u is equal to 20 meter per second and final velocity v is equal to 0. Let the time taken be t. Acceleration a is equal to v minus u by t, that is equal to 0 minus 20 by t. So acceleration will be minus 20 by t. F is equal to ma, that means minus 10 is equal to 2.5 into minus 20 by t. If you solve, then t is equal to 5 seconds. Remember, if you don't convert the force into returning force, your time will be coming as minus 5 seconds. And time can never come in minus. Time is not a vector quantity and time is unidirectional. So minus 5 seconds cannot come. So we have to convert the force to returning force in this sum.